Good afternoon, friends. Today I am going to discuss the Module 2, Chapter 2 of your subject Analog and Digital Electronic Circuit, a chapter called Operational Amplifier. Previous to this, we have already read some of the amplifier characteristic, that is well known as bipolar junction transistor. One is the BJT and the second was the FET. That is a bipolar junction transistor, first one, and the second one is field effect transistor. Field effect transistor. So in bipolar junction transistor we have read something, how to calculate the input impedance, how to calculate the output impedance, then you are interested for the voltage gain and you are interested for the current gain. So similar to the BJT, we also move to JFET. Also you have calculate the input impedance, also you have calculate the output impedance and the voltage gain. So if these are the things is available, then why should I go for the, that is operational amplifier. So operational amplifier is an ideal amplifier. Now my question is, what do we mean by an ideal amplifier? So a amplifier is a device which strengthen the input signals by some amount. For an example, I say, if my input side, in my input side I am giving suppose 50 volt, in the output side I am expecting something, and that value must be greater than 50, and that greater than 50, maybe it is in the output side V0 I am getting some A into 50, where A is nothing but the gain of the amplifier. I am talking about only amplifier, that is the gain of the amplifier. Now similar to the in the BJT also you are amplifying something, in the FET also you are amplifying something. Right now what you are amplifying? You are amplifying the input signal levels. If the input signal I am giving something, maybe it is 20 volt, in the output I am getting 1 volt, millivolt 1 volt, that means my signal is amplified by some fraction or some amount, or the amount is equal to A, where A is the amplifier gain, I can say. That is nothing but the output by input, we are calculating like this. Now here the open say also it is a operational amplifier. In the strike also first, what is the name called? So operational. Also the amplifier, it does the same thing, it is amplified the signal, right? So the meaning is operational amplifier. Why the name is called operational? It is called operational amplifier because it is doing some operation on signals, and the operation are very simple. That means whenever I am giving the op-amp some input device, again op-amp have a 2 input terminal. So op-amp will take 2 input, let it is input 1 and it is input 2. So whenever I am giving a op-amp 2 input things, then I got output, whenever I got the output, that output will be coming in terms of maybe addition of these two. Maybe it is V1 plus V2, maybe it is V1 minus V2, maybe it is some integration of the input, maybe it is some differentiation of the input. Again I say, if I am giving a suppose a signal like this in V1 and I am giving another signal like this at a V2, and suppose this having amplitude peak to peak is equal to 20 millivolt, and this also having suppose 20 millivolt. Peak to peak signal of this input and this input is 20 millivolt both. Then what actually happen in the output? In the output I can say 20 plus 20 is equal to 40 into some gain. That gain I can say in the V0 I am getting something 40 millivolt into some gain, that gain is equal to A. That means what output I am getting, it is simply addition of 2 signals into the amplifier times. Am I clear? What does the operation mean? The operation means it is doing some manipulation on signals. Whatever the input signal I am applying, again op-amp is a 2-terminal device, I say. So as it is a 2-terminal device, one terminal is input, the another terminal also for the input. And in the output also it have another terminal 6. It is the pin number 6. In the pin number 6 I have to collect my output. So input whatever I am giving, maybe it is 2 input signal I am applying, maybe it is doing addition, maybe it is doing the subtraction, maybe it is differentiation, maybe it is integration. That's why the name is called operational. Operational amplifier. It is amplifying with some operation, and that are the operation are addition, subtraction, integration and differentiation. Maybe some other will be there, right? Just the next is pin diagram like BJT and FPD. Unlike BJT and FPD, we don't have pin diagram, but op-amp is readily available in the forms of chip, in form of integrated chip. So I say if I have a op-amp, that op-amp, again I say it is 741, is heavily available in the market. The pin number is 741 DIP, that is dual in package. 741 integrated chip is available in the market, and it have 8 pin. So 1, 2, 3, 4, 5, 6, 7 and 8. I already told op-amp is a device which take 2 input, right now. So if I am going to plot my op-amp figure over here, I say op-amp is looking like simply a triangle. It will take 2 inputs. So from 2, 1 input, and from 3 it is 1 input. So I can say this is a input terminal and this is inverting terminal, and this 3 is the non-inverting terminal. And this 3 is the non-inverting terminal. 1 is the offset null. And the 4th is for minus VCC. Similarly, I have 8 for no connections, and for 7 for VCC, and for 6 it will be the output, and for 5 again it is offset null. Again it is offset null. I am coming to this point, pin diagram of an op-amp. Again, any op-amp which is available in the market, I say it is the pin number is 741 DIP, that is a number. That number is 741 dual integrated package. It have 8 pin, 1, 2, 3, 4, 5, 6, 7, 8. I say for me only 2 things are required here. Here I have to give input terminal through the pin number 2 and the pin number 3. Again, in the output I have to take from the 6 number pin. So any integrated circuit or any device to work, it must be stabilized, right now. Like BJT, you are applying a VCC, right? To fix the Q point. Here the Q point will not be fixed, but I have to stabilize my op-amp. So for that I have to apply something called VCC and VEE. 2 DC voltage is required. 1 DC voltage I am giving VCC with the help of 7. The 7 is a pin diagram, or I can say pin connection. Through this 7 pin I have to set VCC. Again through this 4 pin I have to apply VEE. And here the 2 and 3 are the 2 input terminal. The 2 pin, I say it is inverting terminal. This is important and it will play a major role in the next of the lecture, I can say. The lecture means this pin number 3 is called the non-inverting terminal, right now. So this is the about the pin diagram configuration. Then this op-amp. Now I am coming finally, whenever I am dealing with, so the op-amp figure will be like this. I say it is minus, it is plus. Here it is V1 and here it is V2. And as it is connected to the minus, I say it is inverting terminal. And it is connected to the plus, it is called as non-inverting terminal. Generally, maximum book you find this VCC and VEE will be at this point, the corresponding pin diagram is equal to 4 and 7. So VCC for 7 If I am right, then 4 is for minus VEE. And here in the pin number 6, I have to take the outputs. Right? So finally I can say a op-amp is a device which takes 2 inputs and it will give 1 output. And to make the circuit stabilized, I need a VCC and another VEE. 2 power supply I need. Right? After all, the op-amp is an amplifier. Now I am coming to this V1 and V2. Again I say my V1 is a terminal, or whenever my minus sign is connected, if there I am applying some voltage, that voltage will be treated as inverting voltage. INVERT. Here T is misplaced there. Okay. Inverting amplifier, and if I will apply my voltage signals to a plus terminal, then that is called a non-inverting amplifier. Now the meaning of this is like this. Now sometimes I may apply my input signal like this, and the maximum voltage is equal to maybe 10 millivolt. And I say here it is equal to Vi, and that is with respect to time. Right now. And suppose the amplifier have a gain of 100. All of you know the gain is a dimensionless quantity. So suppose the gain of the amplifier or this op-amp is equal to 100. In the output side, I am going to find another signals right now. So I am going to find the same replica of this type of signals as it is applied in the negative here. That means this is V1. I say this is V1. The V1 is applied in the minus sign. As it is applied in the minus sign, again it is called a inverting terminal. I am going to see my output which is 100 times more, or but with a 180 degree phase shift. Clear? As it is applying with the minus sign my signals, then I am going to see the output waveform which is V0. This is equal to around 100 and this is equal to T, but it is 180 degree phase shift. Right? But if I will apply my signals in the non-inverting terminal, if I am going to, if I say if this is equal to V2, okay, now V1 is equal to 0 and I have some signal in V2, then what I am going to see, I am going to see some A times of V2, but it is non-invert. The name it is non-inverting, it is non-invert, that means within the phase. So this diagram will not come, then it will come this type of figure without any phase change, and the amplitude becomes 100. Here it is minus 100, 0. At least all of you understood what do you mean by inverting terminal and what do you mean by non-inverting terminal. Inverting terminal means the output will be invert by 180 degree. Non-inverting terminal means the output will not invert, that is it will become within the same phase of the input. Right? So there itself pin diagram. In the pin diagram I have to only explain here inverting and non-inverting, then output all of you know, 4 and 7 all of you know. Then another is there offset null, I think, 1 point. So offset null, actually it was from the specification point of view, I say whenever an ideal op-amp was designed, I say some of the input if applied then it will give some output. Am I right? Now whenever there is no input, the op-amp should not give any output. Right now? But practically this thing is not happening. Even if I am not applying any input, the op-amp is give some output, suppose called X. Maybe the X is a very small quantity. So this is the erroneous voltage, I can say. Right now. So in order to nullify this erroneous voltage, I have to apply some DC voltage at V1 and V2. In order to make this X is equal to 0, I have to apply this voltage, means 2 voltage at this point. Right now. So for that 2 offset was there, offset null. In order to nullify the output voltage to 0 whenever there is no input signal. That is the purpose why 2 pins are there for the offset null. Right? Then its equivalent diagram. Actually what is there inside the op-amp that I am going to do, I say it is a minus terminal and it is a plus terminal. This you already know. And this is, I can say, pin number 2 and this is the pin number 3, right now. And this is pin number 6. Pin number is not that much of important. Then I say here it is V1 and here it is V2, right? Every op-amp have a internal resistance like the BJT or like the FET. In case of FET, I say the input impedance is equal to infinite, right now. So for the timing, I am not consider the ideal characteristic. It is the internal characteristic of op-amp. In the op-amp, in the inside there is a resistance is there, and here I can say like this. This is V0 and in the op-amp there is a output impedance R0 and there is a voltage source a VID, where A is the gain of the amplifier. This diagram will give a lot. Like your BJT or FPT, in the op-amp also have a small signal model or the equivalent diagram of an op-amp. And the equivalent diagram of op-amp, it say like this. Op-amp is a device which have some input impedance. I say suppose the input impedance Zi is equal to Ri, okay, and it have some output impedance. Whenever you are going to calculate the output impedance, you have to sort the voltage source. I say it is only R0 is my output impedance. Again, I can say op-amp is a device where the output voltage is equal to A into VID if this R0 is equal to 0. So basically I can say this is the equivalent diagram of an op-amp. Okay. Then I am coming to next to give the heading ideal op-amp characteristic. Achha, first point, the input impedance is very high. The input impedance is very high. So I can say Zi is equal to infinite. For an op-amp, the first ideal characteristic is input impedance is very high. The second ideal characteristic of op-amp, that is output impedance Z0. Z0 is equal to very low and ideally it is 0. I say ideal characteristic, so it will be infinite and 0. Then for an amplifier, what should be the gain generally? For an ideal amplifier, what must be the gain? For an ideal amplifier, I am going to design an amplifier. If I am giving input is equal to 1 millivolt, what should I want to see my output? As much high as possible. Right now, so for an ideal amplifier, op-amp gain is equal to infinite. Again, I already defined something called offset null, right now. So even if I am not giving any input signal, I am getting some output voltage. So that voltage is the erroneous voltage, I can say. So in order to nullify that erroneous voltage, I have to give some bias at the pin number. I already explained that pin. I might be it is 2 or 7 or 1 or 7 like this, right now. So another ideal characteristic of op-amp is whenever, just write, whenever input is equal to 0, whenever input is equal to 0, it must give 0 output. It must give 0 output. Right? means 0 input, 0 output. If input nahi, then there is no output. That is the ideal characteristic of op-amp. But practically the op-amp will not feel like this. Even if I am not applying any input voltage, it gives some voltage. That voltage is the erroneous voltage. Another point I can say, infinite CMRR. Just make it infinite CMRR. Infinite common mode rejection ratio. Just write down. Infinite common mode rejection ratio. That maybe after 2 or 3 class I'll come to common mode rejection ratio. Actually it will help to nullify the noise parts. Common mode rejection ratio will reject the noise. Another ideal characteristic also is just write infinite slew rate. Infinite slew rate also, that will come after 2 or 3 lecture might be. Infinite slew rate, that is okay. Only just keep this point, infinite slew rate. Next give the heading configuration of op-amp. Again, now whenever I am any analysis I am going to do, always I will take the help of ideal op-amp. Still nothing is ideal, but for the practice I have to take the ideal op-amp for rest of the topic. Okay. Ideal op-amp means Ri is equal to infinite. This R0 is equal to 0. So if R0 is equal to 0, what is V0? Can anybody say now? I said this R0 is equal to 0. R0 is equal to 0 means it is simply short circuit. Right now? So what is V0? V0 is nothing but this point only. So V0 is equal to a VID. Now, what is VID I am asking? VID is the voltage difference between the two terminals. VID is the voltage difference between these two terminals. I say VID is nothing but this voltage. So VID is equal to the V2 minus V1. Point. Whenever both terminal sum of the voltage is applied, then which voltage it is going to be amplified? It is simply take the difference of these two, and that is V2 as it is applied to the plus side. So V2 minus V1, that times of A is my output, where A actual ideal value is equal to infinite, right now. So in general I can say V0 is equal to A into VID. Clear? And another also ideal characteristic op-amp, I say op-amp having very infinite resistance at the input, right now. Infinite resistance at the input. What is the meaning of this? Infinite resistance at the input means op-amp is a device which not take any current, right now. So I can say it is a open circuit. If it is a open circuit, that means I can say it not take any currents, but it gives some output, and the output is again it depend upon A into VID. That's why it is A into VID. Now I relate these things to your BJT and APT, then op-amp. In case of BJT, it might be known IC is equal to, the output characteristic was IC, right now. If you draw the block diagram, if you remember, the diagram was like this, beta IB was there, the current source, right now. But here it is same type of thing, but it is a voltage source, right? So IC is equal to beta IB. Output current is depend upon the input current. That's why it is a current control current device. In case of your JPT, it was GM VGS, right now. ID is equal to GM VGS. So my output current is controlled by the input voltage. That's why it is a voltage control current device. Now in this case, my V0 is the output voltage, is controlled by a parameter A into VID. Am I right? Where VID is the input voltage, or I can say the differentiation of, or the difference of the input voltage. VID is nothing but V2 minus V1, but I am getting output is equal to A into VID. So the output voltage is controlled by the input voltage. It is the most important, what is the difference between BJT, FET and op-amp in terms of control device. Then in configuration, I have always took the negative feedback and a closed loop system, not open loop system. Still now my discussion was. So in the configuration, first one is inverting amplifier, op-amp. I already told, if it is a inverting op-amp, that means where should my voltage will be applied? I said the circuit diagram was like this. So it is minus and it is plus, right? I say it was grounded and V0, I say it is a closed loop. As it is a closed loop, then it must follow a feedback. What is the meaning of feedback? If some portion of the output is again back to the input, right now. So I say output will be again back to the input. Input is nothing but at this point. I say it is a inverting op-amp. As it is a inverting op-amp, I say I am applying my AC signal at this point. So it is a V in. All of you understood the circuit diagram at least. I say it is a inverting op-amp and I am doing this configuration with the help of feedback, and it is a closed loop negative feedback I am considering. Why? Because negative feedback are more stable than the positive feedback. So from the negatives, or I can say some of the output again is back to the input. Okay. I say here is equal to V1 and here is equal to V2. Here also I am going to talk a simple concept. I say this is equal to R1. Already I discussed some of the point that op-amp is a device which having very high input impedance, right now. That means I can say to the op-amp there is no current. Inside the, as it is going to face a high impedance, so no current will be flow inside the op-amp. So whatever the current is generated, all the current will be passes over there, right? So whatever the current it will generate, all the current will be passes over here. That is one point. Again, for ideal op-amp, I also say, okay, V is equal to how much? V0 is equal to A into VID. For an ideal op-amp, what is the value of A? Infinite, na? I already told the classification of ideal op-amp. For an ideal op-amp, my A value must be tends to infinite. So in general I can say A is equal to how much? V0 by VID. Acha. Under what condition my A tends to infinite? Can anybody say? Under what condition in this equation my A tends to infinite? VID is equal to 0. Right now? That means I can say this, the difference is equal to 0. Right? VID is equal to 0 means, so if VID is equal to 0, then this A tends to infinite. Only that is the condition, then only it obey the ideal characteristic. Now if VID is equal to 0, then what I can say? What is VID? V2 minus V1 must be 0, right? So V2 minus V1 must be equal to 0. What is the meaning of this? V2 is equal to V1. Okay. From now look at here. From this diagram, I say V2 is connected to ground, right now, but V1 is connected to V in. So V1 is not connected to ground, but here again I say if V1 is equal to V2, then it is treated as an ideal op-amp. That means V1 is not connected to ground, but virtually it is connected to ground. The meaning is virtual ground concept. The question may be 2-mark question. What is the meaning of virtual ground concept? The virtual ground concept say even if the V1 node is not connected to ground, in order to satisfy the op-amp to be ideal, VID must be equal to 0. So VID must be equal to 0 means V2 minus V1 is equal to 0. As V2 is connected to ground, so V2 is equal to 0, imply that V1 is equal to 0 even if it is not connected to ground, right? So from this, now I start my derivation. Again from this point I say one point V1 is equal to V2 is equal to 0. from virtual ground concept. Okay? I say whenever you start the op-amp, I need only one thing, that is if you sufficient enough in KCL or KVL, that is more than enough. As it is a high input impedance, so no current will be taken by the op-amp. That means due to the voltage source, some of the current will generate in this path. Right now, let the current is equal to I1, I note it as it is passing through R1. Achha. As there is no current will be flow over here, then all the current will be passes over there. Right now, so this current I say it is IF. That means for this diagram I1 is equal to IF, that is 100% true. Am I right? I1 is equal to IF. Now from that equation if you solve, so I say I1 is equal to IF. Now you apply simple the node equation. What is I1? I1 is nothing but this current. Right now, this current is equal to V in minus V1 by R1. Right now, V in minus V1 by R1. What is IF? IF is nothing but this current. I say V1 minus V0 by Rn. V1 minus V0 by Rn. According to the virtual ground concept, V1 and V2 all are equal to 0. Now I am putting that equation there. So it is V in minus or by R1 is equal to minus V0 by Ra. Right now, from this I can say V0 is equal to minus Rf by R1 into V in. Right? Now from this point also we can conclude that we are getting output here, that is V0 is equal to minus Rf by R1. Rf is this resistance value, R1 is nothing but this resistance value. Resistance value should never be a negative quantity. So minus is there, Rf by R1 is as it is into V in. That means this will be treated as a gain. Right now? And I have seen, I already told, if my voltage will be applied to the negative side, then I see my output with a phase change of 180 degree. That's why this negative sign is coming to the picture. Next. Okay, based upon this I want to give a problem. Okay, let us solve the non-inverting amplifier, then I will give the problem. Okay. Non-inverting amplifier means where should I give the voltage? In the positive side, na? Still I am moving on the configuration of the op-amp. Any idea how to solve? Again the same fundamental concept we can apply. So op-amp is a device which does not take any current. Just before the op-amp I said this is a terminal and this is a terminal, right now? So no current will flow over here, and I say suppose this one is equal to V1 and this is equal to V2. So VID must be equal to 0, right now? So VID must be equal to 0. VID must be equal to 0 means I say V1 is equal to V2. Now the point is, in this case V1 is equal to V2 but not equal to 0. Mind it. Okay, I can say from here it is connected to that path, right now. So in this path the current will flow. But in this path there is no current, na? Because these two are not connected. I say the connection is somewhere internally, like very high input impedance, and it was open. Right now, I can say there is no current flow over here also. Am I true? Here there is no current flow over here. Then can I say V2? Okay, I say it is V in for more convenient. Okay. As there is no current flowing over here, then there is a drop across here is equal to 0, na? Because current into resistance is the drop. So the drop across here is equal to 0. That means this V in is equal to V2. Right now? So V2 is equal to V in. First point. Second point, I can say the potential difference between these two must be equal to 0. So VID must be equal to 0. So VID must be equal to 0 means I say V2 minus V1 must be equal to 0, implies that V2 is equal to V1, right? So V2 is equal to V1 is equal to V in. This point, this is also virtual ground concept, but it is not connected to ground, rather it is connected to some voltage, right now? Now the case is very simple. Again, op-amp will not take any current, right now. If op-amp will not take any current, I say current up here is equal to I1. There is no current, so this current is equal to IF. So I say I1 is equal to IF. Do it. How much you got? V0, how much you got? Achha, with this if you calculate, then it will come V0 1 plus RF by R1 into V in. If you calculate from this, you will get this answer. Okay, otherwise I am doing here. I1 must be equal to IF. If this so, then what is I1? 0 minus V1 by R1. Am I right now? So 0 minus V1 by is equal to IF. V1 minus V0 by V1 minus V0 by RF. Now you can put the value V1 is equal to V2 is equal to V in. So implies that minus V in by R1 is equal to V1 is equal to V in minus V0 by RF. Right though? Okay, RF will be go that side. So minus RF by R1 into V in is equal to V in minus V0. Right though? From that side I can say V0 I can take to that side. Then V0 is equal to V in plus RF by R1 into V in. Imply that I can say, okay, 1 plus RF by R1 into V in is equal to V0. Right now? And I got at this point, from this we can say, if I am giving some input voltage at this point, I am now getting an output which is 1 plus RF by R1. For a fixed value of RF and fixed value of R1, it is coming a positive quantity into V in. Now that means whatever the input I am giving, it will coming some amplifier times without any phase change. Right now? Based upon this, some problem is there. Okay. Try to solve this problem. Find V0 by Vi. from the following figure. $40K, $60K, and there is a feedback. $400K. Find out the gain or find out the V naught by Vi of the following figure, which consists of an op-amp. Any idea? Any idea from anybody? Don't solve, first share your idea. Sneha, how to find? At which point?
The first will take Vi equal to 0.
Huh?
Then V1 equal to V2 equal to 0.
Huh. Then, in this case, what is the value of V1? Huh?
0.
See that? Acha, 1 minute. 1 minute. I am applying my signal Vi at the negative terminal, right now. And the circuit was little, that's why I say you have to apply it efficiently the KCL, KVL or node equation. So op-amp is a device which don't take any current, and I was applying, it was directly to the ground. So I say suppose this is equal to V1 and this is equal to V2. V1 must be equal to V2, right now. And I was connected V2 directly to ground. So V2 is equal to 0. As V2 is equal to 0, this propagates to here. So I say V1 is equal to 0. First point, right now. So that VID is equal to 0. Clear? That means this potential is equal to 0. Now, please look at here, still not over. This potential is equal to 0. If this potential is equal to 0, then can I say this potential also 0? If this potential also 0, already this was grounded. This potential also 0. So there is a potential difference of 0 between this resistance. That means no current will be flow over here. Right now, this point is important. There is no current will flow over here. If it is some other voltage, then there is a current flow. Keep that very important. That's why I say, or we can like this current, because current is generated due to the battery or due to the AC signals. So this current, I can say it is I1. It must be equal to, say, I say suppose some current is moving I2 and some current is flowing over here, say it is I3. Now KCL I can apply at this point. Sum of current in must be equal to sum of current out, right now. So I can say I1 must be equal to I2 plus I3. So from this, then what is I1? I1 is nothing but this current. So Vi minus 0 by 40. Vi minus 0 by 40, and that is K is equal to, what is I2? I2 0 minus 0 by 60. That's why I say it is 0. So 0 plus, what is I3? I3 is nothing but this voltage minus this voltage by 400. This voltage is equal to 0. 0 minus V0, that is minus V0 by 400. This K is important, okay? Then what is V naught by Vi? 10 or minus 10? Then V naught by Vi is equal to minus 10. So find V naught by Vi, it is simply 10 and it is a unitless quantity. right? This was the problem based upon non-inverting, right now. Okay, another question also I have. Find out V0. Acha, all of you just listen. I am asking find out the value of V0 and you have to just check at which point my voltage is applied. At this point. So that means from this I got an idea that it is a non-inverting op-amp. That means my output will be come in phase with the VY. No negative sign, only positive sign it will come. Acha. According to the concept of virtual ground or according to the ideal characteristic of op-amp, I can say like this. This voltage must be equal to this voltage, right now? And the difference is equal to 0. Acha. And this is not connected directly to ground. It was applied, or I say it is V1 and this is V2. First calculate the value of V2, then that must propagate to V1. That is virtual ground concept, what it says. Then how to calculate V2? KVL, or we can say the voltage divider rule. V2 is nothing but the voltage over here, right now. So from this I can say V2 is equal to, the total voltage is equal to 6 into the same branch resistance. The same branch resistance is equal to 6 by the total resistance. So 6 plus 48. 54. 54K. This also K, na? So how much it will come? 0.67 volt, right? So if this is equal to 0.67 volt, then obviously this is equal to 0.67 volt, right? Now we can apply 0 minus 0.67 by 10 is equal to 67 minus V0 by 10. From there we can calculate the value of V0. 1 point. And finally the V0 will come in 1.33 volt. Now listen. How to amplify my strength of the signal at the output side? Because that is 1 plus RF by R1 into V1, right now. So the value of RF if increase, obviously the amplified signal will be increased, right now. Because RF by R1 must be increased, 1 is a constant. Okay. V0 is equal to 1 plus RF by R1 into V1. I can say this is also right, or V in, or if it is a non-inverting, then V0 is equal to minus RF by R1 into V in. In both the cases, I want to strengthen my amplitude of the output signal. What is the case? In both the cases only I have to increase the value of RF, na? Because only the design parameter are my resistance. Right now, if I increase the value of RF and decrease the value of R1, then obviously my V0 will increase. Over here also. RF increase, R1 decrease, V in is always fixed, then I increase my value of V0. Right? Today lecture, I can say we have discussed why the name is called operational amplifier, because we doing some mathematical task. Still now I have not discussed what is the mathematical task with the configuration, that is by using the inverting as well as by using the non-inverting concept, we can do some mathematical task like addition, like subtraction, like integration and differentiation by the help of this inverting and non-inverting. Also we have another configuration, that is differential configuration. Then we have discussed something pin diagram, then its equivalent diagram also we discuss, and from there we derive what is the ideal characteristic of op-amp. Based upon the ideal characteristic of op-amp, we move to the configuration of the op-amp and we solve some problem related to inverting as well as non-inverting op-amp. Any questions from this?